it's a high-level introduction about what is 5G and what its benefits could be. So let's start with the first question. So what is 5G? So 5G is, as an introduction, is the first mobile communications technology that has been specifically designed for industrial sectors. What do we mean by that? Is, as you know, mobile telecommunication technology is a technology that is defined by standards, and that a group of people who regularly sit together and define those standards. Up to now, up to 5G until 4G, the majority of those standards were really aimed at the consumer market, and the mobile technology was really aimed for consumer use. With 5G, the ITU decided that this time it was meant to be also for industrial use, including obviously the machine-to-machine use case. So 5G not only is going to connect people, but it's going to connect machine and everything, basically. This reflects, by the way, in the membership of the 3GPP. So the organization that defines the standard, the 3GPP, had always had a membership that was pretty flat, that was made of the mobile network operators and the equipment vendors. With 5G, the membership completely spiked, because for the first time the industry understood this is also for us. So all of a sudden you had a lot of industrial joining the conversation and putting forward their requirements, what the tech should be doing. So hopefully the 3GPP organization has come up with standards that should answer those needs and those requirements. And if I were to summarize, and this is my summary, I would say 5G is versatile, is to reliable and secure, and 3, highly customizable. And with those 3 big overall specs, let's say, or features, our 5G aims at answering most of the needs of the industrial sector. So going on, so just as a quick reminder, just wanted to put that, what makes a mobile network? First, to start with, you need terminals. So this is that bit here. Could be mobile phone, tablets. With 5G, it's going to be machines. It could be, because basically 5G can connect about anything. So anything can turn into a device, a car, a kettle, a robot, an AGV, about everything. So you need those devices. You need then a spectrum. And it's important to put that here, because there's a strong debate and a strong activity around the spectrum. So you need a spectrum, so that's to transmit the signal between those devices back to the antenna, back and forth, let's say. You need the antennas, otherwise called radio access network or RAN. This may be an expression you may hear quite often. So that refers back to RAN, to these antennas. Then these antennas, they need a backhaul network that's a link, basically linking the antenna back to the central network, to the brain of the network. Obviously, antennas sitting alone in the countryside are absolutely useless. So that's that backhaul network, most of the time, or say often made of fiber, but also wireless, obviously in challenging areas where it's really hard or doesn't make sense economically to lay fiber. You would have a wireless connection made of microwave. You can see on some antennas, if you look around on 4G antennas, you already see that those microwave dishes that are pushing the signal back to. They can go back and hopping. It has to be line of sight, but they can be hopping from antenna to antenna until reaching an antenna that has fiber, and then the signal is pushed back to the center, or the core network. And you need also a core network, that's that central brain, and you need a data network. So good. So the radio access network it's not only, but that the 3 main components or the 3 features of this access were outlined by the 3GPP and the ITU long time ago with this triangle that you may have seen a lot in 5G and you will probably see again and again, and pointing out the three main features, characteristics of 5G in terms of network and how this works with all the use cases. And this triangle helps actually mapping those use cases. So you've got the top of the triangle, it's the EMBB or Enhanced Mobile Broadband. Apologies for all the acronyms. I come from telecommunication. This is an industry that uses a lot of acronyms. And these acronyms, I believe you will hear them a lot. So I feel like it's nice to understand what they mean and using them. So EMBB, Enhanced Mobile Broadband, that's the capacity for the network to go very, very, very fast. That's basically very in continuity with what happened from 3G to 4G and 4G to 5G, is going faster and faster and faster. So this is what you basically probably know best. 5G is faster than 4G, but not only, because it also does another characteristic, which is the massive machine type communication, or MMTC, or IoT, massive IoT. That's the capacity for the network to connect a huge number of devices and manage at the same time a huge number of connections without crashing. We're talking about 1 million devices per square kilometer. Compared to 4G, which I think had a maximum of 100,000 simultaneous connection per square kilometer. And the last corner is URLLC, the ultra reliable low latency communication. That's probably the most futuristic and the most groundbreaking feature. It's all about having almost zero error on the network and having a very low latency down to really a couple of milliseconds, which qualifies for real time. So if you now map out the use cases here that are on the left, for instance, a 3D video and 4K screen, you map them out on this triangle, you see that, yeah, the use case, that use case squarely lies with the enhanced mobile broadband. But if you go for a network of sensor, definitely sitting here in that corner of massive IoT. Moving on. So as I said, 5G is not just faster. It's also more connection. It's also reduced latency. And it's also, there's a requirement for IoT devices to have a battery expectancy up to 10 years on a single charge. So moving on. So if you remember at the beginning, I made three statements about 5G. The first one being 5G is versatile. So why is that? The reason being that 5G is often considered actually as a network of network, and that central brain, that core network we talked about, has the ability to connect to other network and manage other networks seamlessly. It's completely agnostic to how the signal comes into the network. It could be Ethernet, it could be Wi-Fi, LP1, Sigfox, Bluetooth. The brain, the 5G brain, doesn't care. For the brain, it's just another form of signal. So 5G can act as an umbrella system. It's not only versatile, but also it's kind of future-proof. So if ever there was another communication technology coming in, 5G would just take it in and just incorporate that in that single umbrella solution. The next statement was about 5G being secure and reliable. So the security lies in the fact that 5G has been designed to be secure, and the security hasn't been put on top, but really at the heart, at the design of 5G. The reliability and the security also lies on the private networks and the mobile edge cloud. So what does this mean? So with 5G, you have the ability to build your own independent 5G private network and including all the brain and all the, what we call the mobile edge cloud, all that being locally, which allows obviously greater security and privacy of what's going on a network at, let's say, a factory size, or it could be a university campus, ring fencing this network and having complete authority and complete control of that network. And the last statement I made about 5G being highly customizable, this customizability rely on a feature called network slicing. So for those who don't know, it's a technology that allows 5G network to be subsliced, or to carve out within a 5G network a part of network that will be dedicated to a specific set of users. And you can carve out as many sub-network as you want. So let's take an example. You are in a factory, you would like to, you've got people or machines using that network, that 5G network you have. One is your production line with robots. Another one is operators having augmented reality glasses and connected in 5G. And maybe another set of users could be visitors coming in the factory and visiting the factory. Obviously, they don't have the same requirements. Not only they don't have the same requirements in terms of network and speed and latency, but don't have the same, or QoS, but also don't have the same level of priority. And you can completely customize your network and make sure that, let's say, your production line always gets first priority and gets the best latency and get the best bandwidth, in order to ensure that production line always gets the network requirement that it's necessary to make it work all the time. Your visitors, I would probably say, comes last. And if for whatever reason there is an emergency on the production line and you need more network, you automatically, the network can expand and give more bandwidth, let's say, and push back your visitors and push back the visitors from the network and allow that network to be dedicated only for that use case. That would be, let's say, robots needing extra capacity and extra capacity to work. So now let's go to the benefits and opportunities of 5G. So this is I've laid out 3 slides that are actually an extract of a report we made called Made in 5G, where we basically grouped or made clusters of use cases and the benefits they could bring in 3 groups, all those use cases for the manufacturing sector into 3 groups. The first group of use cases was the on-site and in-factory production optimization, and how you could use 5G, for example, for your robots and cobots to make them more responsive, more intelligent, and more configurable, with the idea of having all the intelligence on the cloud and no longer on the robot, and having all those robots being completely coordinated and sync in real time. You could have also a time-critical hazard detection. I'll show you later a video of a trial done by Audi, where they using 5G, and how the real-time 5G allowed for more security on the production line. You could also use 5G for immersive assisted operation. Again, I'll show a video later. But I mean, I would say you could connect about anything on a factory floor, from the rooftop to the people, to the robots, to the AGVs, the warehouse. So basically the sky is the limit in terms of potential usage of 5G. The next cluster of usage is the use of 5G to monitor and manage the goods across the supply chain. So either the goods coming in or the goods going out. And depending on the industry and how critical it is, you could monitor real time the location, but you could also monitor the condition also of your assets, not only the condition of the goods, but the condition of the assets that is carrying the good. Could be a truck, could be a train. Yep. So again, a lot of potential use cases here. And the next and last one is maybe the most challenging, but potentially the use case that can bring the most value. It's about connecting the goods that are produced in order to allow in-service maintenance and end-of-life management. So that's the idea of, it serves also the idea of the servitization of the goods. So once you connect your good and you have, after delivery to the customer, a complete understanding of what is happening with that good, when maintenance is required or when it needs to be decommissioned, you can start selling maintenance packages and maintenance services that are proactive and more effective, or even as an example, you can start to sell a service instead of selling a good. So that's this idea of, for instance, Bosch, instead of selling a boiler, would sell heat as a service. And with the ability to monitor in real time that boiler, they also are able then to guarantee that heat at home 99% of the time, and maintenance within 1 hour. I'm just inventing, but that's the type of potential services that are available. So the next part of this presentation is about the 5G ecosystem. I'm going to be very simple here because it's a bit more complex here, but first, let's go into the 5G value chain and how it all pans out. So to start with, you need the equipment vendors. These are both the big equipment vendors, the ones that are providing all the equipment required to build the network, but these are also the devices manufacturers. They provide all this equipment to mobile network operators that then build everything and operate and maintain a network. On top of that come application providers and then the distributors, going at the end to the industrial end users. I will enter the detail now here and give a bit of some examples and some names so that we can start to have a better understanding. So remember, if I go in previous slide, the first one is the 5G equipment vendors. They are made, as I said, of those equipment, hard network equipment providers, and they are made also of the devices providers. But within each ecosystem, you've got subgroups. So you've got the big network equipment providers. You've heard Ericsson, Nokia, Huawei, Samsung, Cisco. These people are selling antenna, servers, big equipment at the core of 5G. You also have some software coming on top to enhance and bring even more value to those networks. So you could have customer services software like Hitachi, Siemens, or a billing platform, or an edge compute platform. As we've seen, it's very important to 5G. So Microsoft, Amazon, for instance, are names that you will have heard probably in that 5G world. If you go to the devices ecosystem, again, and you could really cut it even really finer and finer. But let's say those groups, you would say you would have the software components manufacturers. So for instance, the operating system on devices. At the moment, you have Google, Android, Apple, Microsoft are big OS providers. You've got hardware component manufacturers. The main one, obviously, you've got many pieces of hardware to make a device, but really at the core of it, it's all about the chipset, the 5G chipset, and the big name in that industry is Qualcomm. You've got mobile device manufacturers. So these are people who are putting everything together to make a device. So in the consumer world, we know them: Samsung, LG, Huawei, HTC, Apple, Sony, OnePlus. Others are coming, but these are the big names. In the sensors manufacturers, I've put here a few names: TI, ARM, Bosch, PTC. There are many, many others. But this gives you an idea of who we are talking about. So then those people are providing all those equipment to the network operators ecosystem. Those mobile network operators, you may think about the traditional one are known as the 302EE Vodafone. These are the 4 MNOs that have bought 5G spectrum and have a license to sell 5G spectrum. But there are a lot in 5G. There will be a lot of other players that will enter that world, and in a way or another, could potentially be network operators. So we say IoT network operators or internet service providers or MVNO or fixed network operators. We, for instance, in the UK, we're also working with Verizon, who has a strong ambition also in 5G. So there are a number of other operators. And in the OTT or over-the-top ecosystem, in my previous life, I come back, I had put the application providers and the distributors. You can find them here. So I've put mobile application here. These are your consumer mobile applications. To my knowledge, for industry, I've yet to see a 5G solution application specific for industry. Days. And in terms of distribution, if you go in the consumer world again, these are your traditional retailer: Carrefour, Warehouse, Tesco, all the alike, which are obviously irrelevant for industry or for most of the industrial application. And we believe that this role of distributors is going to be endorsed by the system integrators like IBM, Accenture, Capgemini. All those people will potentially could act as a go-between between the network operators and the industrial end users. So where are we in the UK? Actually, in the UK, we are in a very good position for 5G, contrary to 4G, where the UK missed a bit the boat. It's looking good for 5G. So as you know, in 2019, the 4 UK MNOs launched their 5G offer, which is, according to DCMS, was 18 months earlier than what was predicted. We see a lot of, all the mobile operators are in agreement to say that the industrial application are absolutely the greatest opportunity. This good position, as I have to say that the mobile network operators have had a were instrumental into making the UK in such a strong position, but also the government. And for instance, the 5G Testbed and Trial program, which is a 5-year-long program, had, as we know, has put a lot of funding towards adoption of 5G. There was also the UK 5G Association that was created. Ofcom also has had a a lot to do in releasing spectrum at the right time and really, really fast. However, it's still very early days. The standards are still being defined. As you know, the standard in mobile telecommunication comes by batch, and a batch is called a release. So we are waiting for, I think we are on release 15, release 16 is coming, and release 17 also will be coming in a couple of years. So there's still some bits and pieces. I shouldn't say bits and pieces, but it's work in progress, basically. And plus the value chain, as I explained, is still facing challenges. So if you look at here, at this value chain, what we hear is, this is what we've heard, and in some instances in that value chain. So the equipment vendors are saying that they would like the adoption to be a bit quicker than what it is. They've put massive investments, obviously, in developing all those 5G equipment. For the mobile network operators, they definitely see 5G as an opportunity, but the industrial use of 5G is not their primary area of expertise. They come from more a consumer world. The application providers, as we've seen in the mobile telecommunication world, they were 99% dedicated to the consumer market. And those people have extremely limited knowledge and probably will actually to enter that industrial market. And as for the distributors, same thing. The current distributors in the mobile telecommunication world are not geared at all to address industrial usage. And for the industrial end users, we see a really strong interest, really peaking, but same thing is, what's the benefit? What does it mean? What is it exactly? I'm not sure I want to go to a mobile operator. I don't know where to go to start playing with the tech. So here, I've put some examples of industrial use cases. I've put them in a video. I feel it's always better. So the first one is it's a video that was done by Ericsson with Audi, and it's a trial, as I mentioned at the beginning of this presentation, in a factory, in an Audi factory, on a robot cell, and how could 5G improve the safety.
The benefits of factory automation with 5G is the gain of flexibility and mobility of the production equipment, such as robots adapted on HUVs. URLC is the basic for guaranteed data transmission and therefore the first requirement for personal safety applications.
5G URLC stands for 5G ultra reliable low latency communication. So the signal will never use more than 3 milliseconds, for instance. And that is actually the communication characteristics that are needed for certain applications, and Profinet is one of those.
Our goal with this URLC project was to showcase that we can run our regular automation in the factory with the wireless communication. And we needed determinism, which up to now Wi-Fi standards cannot provide.
So we are showing an example here that to transport safety protocols, the underlying mechanisms need to be very stable and reliable. And that is what 5G URLC brings. The demo shows a robot cell that is connected via 5G. And then we have a laser curtain that protects one side of the cell so that if someone reaches into the robot cell, and the robot stops, so that no one can get hurt. And the laser curtain uses ProfiSelf as a protocol to secure functional safety of an application.
In factory automation, having to synchronize all the machines, the robot equipments together with the PLCs, we need deterministic low latency communication. And up to now, this was only doable through wired networks. But if we want to be more flexible in the future, we need to omit those cables and we need to come to a wireless communication. This is something that in the end will then benefit the entire world that is working in production, because they will be able to use a 5G network to drive their operations.
As I said, we have other examples, and for put here a video about 5G and V2X or connected vehicles. It doesn't have any explanation, but I thought it was explaining quite nicely through the video. It's from taken on a stand how what's the difference between 5G and current technology, what it can bring to the connected vehicle ecosystem. So in the appendix, you will see I've got other ones, many other videos. One about Atlas Copco, it was, I think it's in Belgium, this one, the Smart Harbor mining, all illustrating various aspects of the features I talk about 5G and how they could serve an industry. And I've got even more here. For people, the GSMA video is a good one about explaining for people who really want to understand the V2X. It's a very good introductory, high-level introductory video about V2X and connected vehicle. So thank you very much, everybody.